Welcome to Emilak Online tutorial. Now before us is this question in linear motion. Calculate the instantaneous velocity at 7 seconds of a rocket undergoing uniformly accelerated motion if the position is given by s equals to the above this equation. Now where s is in meters and t is in seconds. Now here are the available options. Now, looking at the question, we are given that the position is given by this equation, which means that the position s now is in relation to the time t. Okay, now in this case, now how then do we find the instantaneous velocity? Now let us recall that displacement equals the velocity times time, right? Now, and in terms of differentiation here, now we can assess that for us to find the value of t here, it implies that we will need to differentiate the position with respect to t, which implies that the s all over the t will then give us what? V. Now, which also, let me probably still break it down here. It means the s all over the t will give us that V, which is actually what we're looking for. Then our time here, which is what we are differentiating with, will give us 1 minus 1. And take note that this one we actually have be a coefficient here. So to that end, we have that V equals, Vt raised to the power of what? 0. And anything raised to the power of 0 is 1. So we end up having this equation. So which implies that for us to have V here, it means we have to differentiate the position with respect to the time. So here we have that the s all over the t will then be 5 times 1 times t raised to the power of 1 minus, that's in by differentiation, here's the method, then plus 12 times 2 times t raised to the power of 2 minus 1. Now to this end, we can now say the s all over the t then equals 5, because this one becomes t raised to the power of what? 0, and anything raised to the power of 0 is 1. So then plus, here you have 24 t. Okay, now we can see that the t, the s actually equals to V, so we represent this, or rather replace it with V equals to what? 5 now plus 24t. Now when at 7 seconds, which means at t equals to 7 seconds, then our V equals 5 then plus 24 times 7, which means you have to plug in 7 where you have t. So at the end of the day, we have what, by punching our calculator here, we have 173 meter per second square. So B is the answer. Alright, thank you and God bless you. Okay, now let's look at number 2 question in linear motion. Now, two bodies x and y start from rest and move uniform acceleration of a and 4a respectively. Now, if the bodies cover the same distance in t sub x and t sub y, then the ratio of t sub x to t sub y is, and we're given the option. Alright, now let us take note that when a body starts from rest, it implies that the initial velocity u will be equals to 0. Okay, now for x, for body x, the acceleration a equals a, and for body y, the acceleration equals 4a. Okay, let us just make this sub x and sub y. All right, and for the time we are giving it is t sub x and t sub y respectively. All right, now let us now make use of this equation. Okay, now for x, we can say here that equals ut sub x plus ax t square x all over 2. All right, now if that be the case, now it implies, now take note that u is 0, and since it is 0, it means the whole of this ut sub x is 0, and now we are left with a sub x t sub x square then 2 over 2. Okay, which implies here that our a here, it is a, then t square sub x all over 2. Okay, so which means the distance for distance x here is the final equation. Now for y, since the same thing here, our u is 0, it implies that ut is 0. Then for here we have that a sub y, then t square sub y all over 2, then equals, and a sub y is 4a, then t squared sub y all over 2, so we end up having 2a t raised to the power of 2 sub y. Okay, because 2 here 1, 2 here will give us what? 2. Now but the question says that the body cover the same distance, which implies that s sub t equals s sub y, so which implies that if s of t equals to s of y, so we can literally say that a t square sub x all over 2 then equals 2a t square sub y. Okay, now and if that's the case, so let us we are looking for t sub y, right? So we can, let us do like this, let us multiply both sides by 2 all over a times 2 all over a. So a will cancel a, 2 will cancel 2. Okay, so here we are left with that t square sub x equals 2 times 2. Okay, this a will eliminate a, so we are left with 4t square sub y. Now dividing both sides by t square sub y, so we are now left with this. And recall, according to the law of indices, when you have a raised to the power of 2 all over b raised to the power of 2, is the same thing as saying a all over b all raised to the power of 2. To that end, we can now say that t sub x all over t sub y all raised to the power of 2 equals 4. Alright, now let us square both sides. Now take note, this is plus or minus, so we end up having plus or minus 2 seconds, but our negative sign is not valid, so here we have that 2 seconds as the final answer. Okay, so to that end, now we can see here that t sub x all over t sub y equals 2, which is also the same thing as 2 all over 1, which can also be written in form of ratio as 2:1. Okay, so to that end, 2:1, then C is the final answer. All right, let's move to the next question. Now, looking at this question, you're told that if a car starts from rest and moves with a uniform acceleration of 10 meters per second square for 10 seconds, and the distance it covers in the last 1 second of its motion is, and we're given this option. Now here is the diagram, okay, which means this is the velocity and here is the time. Okay, all right, now this is a velocity time graph because it is a graph of velocity with respect to time. Now it implies that at 90 meters per second, that's traveled in 9 seconds. Then in 10 seconds, now the speed or the velocity is 100 meters per second. Alright, now to this end, the question now is the distance it covered in the last 1 second. So in the last 1 second is between 10 and 9. So the 9th second, the 10th seconds minus the 9th seconds. Alright, now take note, since it starts from rest, our u is 0. Alright, now making use of this equation, okay, so to that end, the whole of ut is 0 because our initial velocity is 0 because the car starts from rest. So at the end of the day, our equation becomes at squared all over what? 2. Now to this end, our a, which is acceleration, is given as 10 meters per second square. Okay, now since we are asked to find the distance in the last 1 second, now it means if the distance, so here we have that the distance will now become a then times t square for the 10th second minus t square for the 9th second all over 2. Okay, right. So to that end, we have that this is 10, then into, now for the 10th second here, you have what? 10 raised to the power of 2. Okay, let me just do it like this. Since this is, you have 10 raised to the power of 2, which is what? 100, minus 9 raised to the power of 2, which is what? 81. And at the end of the day, we end up having this will be 19, then all over 2. Now 2 here 1, 2 here 2, so we end up, 5. So we end up having it should be 95 meters. Alright, and C is the right answer for the question. Alright, thank you. Alright, number 4 here says a ball is thrown vertically upwards from the top of a building with velocity of 10 meters per second. If it takes 4 seconds for the ball to reach the ground level, the height of the building is, and these are the options given. Now let me draw, assume this is the building, okay, and this is thrown from here down. Okay, this is the ground level. Okay, now we assume here, from here down, this is the height of the building H, and here is the height of the projection from the top of the building. Let us say this is S. Okay, let me just use Y. Okay, alright, and we are told here that the total time is 4 seconds. Alright, to this end, let us find the time it takes the ball to get to this point. Okay, so at this point the ball will be stationary, which implies that v equals to what? 0 here. Okay, so at this point, and our u is 10 meters per second. Okay, to this end, let us find the time. Now using this formula that v equals to u plus AT. And take note that since it is vertical, our A equals negative G. So to that end, here we have 0 equals U minus G then T. So at the end of the day, we have negative U equals negative GT. So, and T here would then be, since we are negative, then our U is 10 all over 10, which is what? 1 second. So which means the time taken for the ball to reach here is 1 second. Now let us now calculate the height. Now travel. Now making use of this formula, v square equals to u square plus 2a s. Okay, so at this point now, take note that our a also is what? G, because it's traveling vertically. And at this point also, our v here is what? 0, because this is the maximum height, and our u is still 10 meter per second square. Alright, to that end, we can say this is our 0 equals to u square minus 2 times 10 times s. Alright, sorry, I've actually made this y, so here will be what? Y. Okay, so to this end, we have our u's here will come over here. So here we have negative u square equals negative 20y. So this will be negative 100 then equals negative 20y. Take note that this is not 100. Our negative u square is different from negative u all raised to the power of 2. For this is negative 100, and for this is just what? 100. So take note of that. So to that end, let us divide both sides by 20. So our y will now become 5 meter. Okay, so to that end now, it means from here to here is 5 meter. Alright, so let us now calculate the total height, and take note that from here to here is 1 second by our calculation. So for us to get the total height, let us make it as h then equals to ut plus at square all over 2. Okay, where our capital H equals y plus what? H. Okay, so to this end here now, our u here will be 0 because it's starting from rest. So here you have that h equals to 0, then plus our g is positive because it's now moving downward. So here we have 10, then times our time here. Take note that for the total time it is 4 seconds, and from here to here is 1, right? So it implies that the remaining part here will now be 4 minus 1, which is what? 3 seconds. So here we have 3 raised to the power of 2 all over 2. 2 here 1, 2 here 5. So here we have 5 times 9, which will give us what? 45 meter. Now if h plus equals to y plus small h, so here we have that 45 equals 5 plus small h. So here you have subtracting 5 from both sides, so we end up having 40 then equals to what? H. So our h here is what? 40 meter. So B is the final answer. Alright, thank you. Alright, number 5 says here, a body starts from rest and moves with uniform acceleration of 6 meter per second square. What distance does it cover in the third second? I believe we've done something similar like this, probably in the first or the second example. If you can do this, pause this video, attempt it, and you come back, let us see if you're right. Okay, now from this here, our acceleration is given as 6 meter per second square, Now since it's starting from rest, our u is going to be 0. Okay, now what distance does it cover in the third second? Now in the third second, it means we are looking for the distance is covered within the third and the second. The third and the second second. Yeah. So here S equals to ut plus at squared all over 2. Now we're going to make use of this equation here. Okay, so and the time here is written, I said it's written the third and the second. All right, so and our u here is 0, which implies the whole of the product of ut will be 0. So our S will now be a, then here you have a t for the third second square minus t for the second squared all over 2. So to this end, our a, which is acceleration, that will be 6, then into our third second, that will be 3 raised to the power of 2 minus 2 raised to the power of 2 all over 2. So we end up having 6. Here will be 9 minus 4, which will give us what? 5. Okay, so to that end, 2 here, 1, 2 here, 3. So we end up having 3 times 5, which will give us what? 15 meter. Okay, A, the final answer. All right, thank you. Now let's look at this question. Two balls X and Y weighing 5 grams and 50 kilograms respectively were thrown up vertically at the same time with a velocity of 100 meters per second. How will their position be 1 second later? Now these are the options. Okay, now let's take note that since the ball is thrown at once, at the same time, it implies that the two of them will have the same velocity or speed rather. Okay, now and the acceleration also will be the same, approximately 10 meters per second square. Okay, so to this end, the distance S equals to ut plus at squared all over 2. Now since it is thrown vertically upward, then it implies that our A will give us what? Negative g. Okay, now to this end, we have that S equals to 100, 1 second later, that will be time, equals 1 times 1, then minus, that will be 10 times 1 square all over 2. So here we have 100 minus 2 here 1, 2 here 5. So here you have 95 meter. Okay, so at this point here we have that X will be 100 meter above of Y. No, X and Y will be both be 95 meter from the point of throw. X and Y will be 100 meter from each other, while Y will be 95 meter ahead of. Now since they are being thrown at the same time, so definitely X and Y will both, this should be will both be at 95 meter from the point of throw. Alright, B is the right answer. Thank you. Now let's look at number 7. The distance moved by a particle in the 6th and 8th second of the motion are 45 meter and 53 meter respectively. Now determine the acceleration of the particle. Now for us, now let's take note that at the 6th second, it implies at times 6 and time 5. Now for the 8th second, Now this imply at time 8 and time 7. Okay, so which implies also here that the distance for the 6 second is 45 meter, and the distance for the 8 second is 53 meter. Okay, now using this equation, so for S6, so S6 will give us U, then T6 minus T5, then plus A into T square 6 minus T square 5 all over 2. Alright, now making use of this equation here we have 45, then equals to U, that will be 6 minus 5, then plus A into that will be 6 squared minus 5 squared all over 2. So to this end we have 45, then equals to U, then plus this will be 36 minus 25, that should be 11. So here we have 11A all over 2. If I have to multiply 2 to both sides, we end up having 90 equals 2U plus 11A. Okay, that's for equation 1. Okay, now S8, that is the distance moved at the 8 second. So here we have still using this formula. So here you have 53, then equals to U into 8 minus 7, then plus A into 8 square minus 7 square all over 2. Okay, so here you have 53 equals U plus, here you have that will be 64 minus 49. This should be 5, that will be 15. So here you have 15A all over 2. Okay, because 8 squared is 64, 7 squared is 49. So multiplying both sides by 2 here, we have 106 equals to 2U plus 15A is equation 2. Okay, let us bring equation 1 here, then equals to 2U, then plus 11A is equation 1. Now subtracting both 1 from 2, here we will have a 6, 1, this is 0, then plus 4A. Now divide both sides by 4, then our A will give us 4 meter per second square. Okay, final answer. Alright, thank you and God bless you. Now looking at this question again, a body which is uniformly retarded comes to rest in 10 seconds after traveling a distance of 20 meters. Calculate its initial velocity. Now here are the options. Now as long as the body is retarded, it means the final velocity will be what? 0. Okay, and time is 10 seconds. The distance is 20 meters. Okay, so to this end we have to find the initial velocity, or the initial velocity. So to this end we have to make use of v square u square plus 2as. Okay, now but acceleration is not given, so let us look for the one that we don't have velocity. So here you have s equals to u plus v t all over 2. Now to this end our v here is 0, so here you have 20 equals in, now our v is 0 plus u is what we're looking for, then time times 10 all over 2. 2 here, 1, 2 here, 5. So this will give us 20 equals 5 u. Okay, then dividing both sides by 5. So our u is 4.0 meter per second square, and that is C question. Option C. All right. Thank you and God bless you. And let's look at this question. Number 9. Here's a diagram, and it says that the diagram illustrates the velocity time graph of the motion of a body. Calculate the total distance covered by the body. Now, the area covered by the distance time graph is actually the distance. Now, let us start. You can see we have 3 shapes here. This is A, B, and C. Okay, and if you take a look at this shape, this is more or less like a trapezium, and take note this is 0. Okay, so to that end, distance covered by A, let me say distance A, a trapezium, that 1/2 A plus B, then height. Now this is our small a, which is 10. 1/2 into what? 10 plus. Then from here is the b, which is 20. Then our height from here to here, that will be 5. So this will be, here now we have 30 times 5/2 to give us 15. Now 15 times 5 here, that should give us 5, remainder 2, that will be 75. Now for distance B, which seems to be a rectangle, so that will be length times breadth, and this should give us here from here to here is 5, and here 20, that will be 20 times 5, this should give us 100 meter. Now the last one, which is C, form of a triangle. Distance covered in C, you have half base times height. Now the base here is 5, because 15 minus 10 is 5, times 20/2, that is the height. So 2 here 1, 2 here 10, so here you have what? 50. Now total distance here now be 100 plus 75 plus 50. So this will be 5. Here will be 12. Should that be 12? Yeah, 12, remainder 1. So D is the final answer. Thank you. Now looking at this number 10 question, the distance traveled by a particle starting from rest is plotted against the graph. So it's plotted against the square of the time elapsed from the commencement of the motion. Now the resultant graph is linear. The slope of this graph is a measure of, now we're given this option: initial displacement, initial velocity, acceleration, half the acceleration, half the initial velocity. Now to actually ascertain this, let us recall that the equation of a straight line graph is given as y equals to mx plus c. Now when y is plotted against x, now we have the slope of m and intercept at c. And a case whereby it's starting from the origin, which means c equals to 0, we end up having y equals to mx, where m is either the slope or the gradient. Now to this end, since this particle start from rest, it implies that u equals to 0, which means for all the equations, equations in linear motion, u is 0. Now since it's that the distance against the time, so we come up with the distance against the time. Okay, and which is set against the square of the time. So this is the perfect equation. So to this end, u here is 0. It implies that our equation becomes s equals to what? At squared all over 2. Okay, now since it is the distance against the square of the time, alright, so let us now equate y equals to mx now plus c. Okay, let us leave c, then to s equals to at squared all over 2. Now you can see that s, see from here y is plotted against x, then m is our slope. Now s is now plotted against the square of the time, so it implies here that m will now be a all over 2. So now the slope of this graph is a measure of half the acceleration. Alright, thank you for watching this video, and if you love what I've done, then kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and mathematics. Thank you and God bless. Let's look at this question here, and it says, now what is the average velocity of the sprinter whose velocity time graph is drawn, is shown above? Now here is the velocity time graph. Pardon me, for it is not drawn to scale. Okay, alright, now how then do we calculate the average velocity? And let us take note that distance equals average speed or average velocity times time. So which implies that the average velocity here, average velocity equals to total distance all over time. Okay, then for us now to get the actual value here, now what we need to do now is to calculate the total distance, and the total distance here is the total area of the diagram. That is the area under the velocity time graph. So this should be velocity in meter per second and the time in second. Okay, so to this end, you can see this shape takes the shape of a trapezium, which will be half into a plus b times height, then all over. Now the total time here, now we have to calculate that. That is from 0 to here, that will be 2. Then from here to here, this is 2 plus 2 plus 2. Okay, now plus another 2. So which means this is 2. That is 1, 2, 3, 4, 5. That should be 10. That will be 2, 4, 6, 8, 10. Alright, now to that end, so it means all here is what? 10. Now our A, our B, then our height. Our height here is, so that will be 10. So here we have the average speed, that will be 1 over 2. Then our A here, that will be from here to here, that will be 2, 4, 6. That will be 6 plus our B, which is from here to here, which is 10. Then times 10 all over 10. So here, this time we'll cancel this. So we are left with 1 all over 2. It will be 16. 2 here 1, 2 here 8. So here we have 8.0 meter per second. So C is the right answer. Alright, thank you.